Okay, let's see this number 12 question. It says, what is mechanical energy? Now, mechanical energy is the energy of an object due to its position or motion. As simple as that. Don't do too much. Now, the second one says, a ball of mass m raised to a height h above the ground is allowed to fall freely towards the ground. So show that at point t, when it has fallen through the distance h, okay, small letter h, the total mechanical energy remains unchanged. Okay, of course, that's according to the conservation of law of mechanical energy. Now, when you have here, okay, at this point here, we have the total height is h, okay, and the mass of the object is capital M. The potential energy is maximum at the height, and it is equal to m, the m, then g, then h. That's mgh, mass times acceleration due to gravity times height, right? Now, but at a point t, because this is the motion, at a point t, it has lost a little kinetic energy. The potential energy at this point t now is going to be, remember it has fallen through a distance h, is going to be mg times small h. That's the potential energy at this point. Then it has a kinetic energy at that point too. The kinetic energy at that point is half m then v squared, the velocity here, that means I'll call it vt squared, the velocity at that point squared. Okay, so that means the total energy, in this case here, the total energy is equal to mgh, but here also total energy is also equal to mg small h plus half mv squared. That's because here the kinetic energy here at the maximum height when it is not moving is equal to 0. So you can put it this way: at the height h, okay, total energy is equal to potential energy plus kinetic energy. That's the kinetic energy. Okay, so the potential energy is mg big H, the kinetic energy is 0, so that means mg big H. Then at t, the total energy, like I mentioned, is equal to mgh then plus half mvt squared. So since total energy is the same, it means that mgh is equal to mgh plus half mvt squared. That is what you are expected to do. You are supposed to show that the total mechanical energy remains unchanged, and that's exactly what we did here. What that simply means is that loss in potential energy becomes a gain in kinetic energy. So as it lost some potential energy, it became a gain in kinetic energy, and makes a lot of sense, right? Now the next one says, what is a thermometric property? A thermometric property is any property that changes with temperature. Any property that can be influenced by a change in temperature is the thermometric property. And here we are asked to complete the table below. We have thermometric substance, we have thermometric property, and we have kind of thermometer. Okay, in the thermometric property for this is length. Okay, the length expansion, right? Then for platinum resistance, the thermometric property is that resistance, okay? And the thermometric substance is platinum wire. Okay? Then for the case of gas as a thermometric substance, right? And the thermometric property is pressure, change in pressure. The kind of thermometer here is called gas thermometer. Here the thermometric substance is dissimilar metals. two different metals. Okay, the thermometric property here is potential difference or voltage. You can say voltage or potential difference, and that thermometer is called thermocouple. Okay, so that leads us to C. An inclined plane is used to raise a box of 2.5 kilograms to the top of the plane by an effort of 180 newtons. Assuming the plane is 60% efficient, calculate the mechanical advantage, velocity ratio, angle the plane makes with the horizontal. Okay, quite easy. If I should draw a diagram here, I have my inclined plane, and let me make this better. So we have this. Okay, we don't know what the angle is, but we have a box whose mass is 25 kilograms. Okay, we go back to the question. It says, okay, there's an effort. They are meant to move this by an effort of 180 newtons. So let me put the effort this way, 180 newtons. That's the effort. Okay, it says the efficiency is 60%, so I can put efficiency here to be 60%. Okay, so the question we are asked to find the mechanical advantage, the velocity ratio, and the angle. Okay, so first of all, the mechanical advantage, based on what I can see here, is always load over effort. Okay, the load is the weight here, which is 25 kg, so that's 250 newtons, converting kg to newtons. Okay, so the effort here is 180. I think 180 newtons. Yeah. So now we are asked, okay, we are meant to divide. So 250 divided by 180. Let me calculate that quickly. Okay, that is giving us 1.39. So this is equal to 1.39. That's the mechanical advantage. Okay, the next question says we should find the velocity ratio. Now remember that efficiency of a machine is mechanical advantage all over the velocity ratio times 100, right? Yeah, so the efficiency is 60. Mechanical advantage is 1.39. The velocity ratio, we don't know what that is. Then multiply by 100. So that means the velocity ratio now is going to be 1.39 times 100 divided by 60. So I can use a calculator to achieve this. So we have 1.39 times 100, then divided by 60. Good, so this is giving us 2.32. So we come back here and write 2.32. Okay, so that's the velocity ratio. Now we have answered that quite easy, right? So the next question says the angle the plane makes with the horizontal. The angle the plane makes with the horizontal. So in this case here, remember that velocity ratio of an inclined plane is also 1 over sine theta. You should note that. So the velocity ratio is 2.32 equal to 1 over sine theta, right? So if you cross multiply, sine theta is equal to 1 over 2.32. So that means sine theta is going to be equal to, so let me divide that, 1 divided by 2.32. And that is giving us 0.431. So this is 0.431. So theta now is going to be sine inverse of 0.431. So let's do that quickly. So we have the sine inverse of 0.431. with a calculator quickly. It's about 25.53 degrees. So we have 25.53 degrees. Okay, so makes a lot of sense, I guess. Makes plenty sense. Okay, so that's the answer. So see you in my next video, okay?